Hello there, VIPs. Good morning to you once more. It's your guy, Mr. Time from Time Engineering Academy, right here. So, with our part 4 yesterday, we stopped at this position, right? We stopped where we're modeling our staircase, and I did explain to you the size of my lifter. Okay, so this lifter is calculated for a capacity of 8 persons. Okay, so whenever you're designing a lifter for a particular area, like shopping center, the sizes are different from a normal residential lifter. Okay, so it's based is the size is being designed calculated based on one the size of the luggages that is going to be carried transported there, and the number of persons that is going to be using the lifter. Okay, so this size of 1.9, that is 1 meter 90 by 1 meter 70, is for 8 persons capacity, right? So with a maximum weight of 630 kilograms. So that is how it's being designed. So a maximum of 630 kilogram is supposed to be transported here. So it's a capacity of 8 persons. So that is how it's being calculated. So we have 1.7 by 1.8. Okay, so this is just a matter of offsetting and then balancing everything. So this again is not, it's still the same principle in offsetting. So I'm just going to mirror this one. So to mirror here, I'll just go to I modify the click on mirror, and then I want to mirror from the center of this line here so that I have equal sizes on both sides. So unfortunately I did not mirror the lifter shaft. Okay, so I'm going to select everything all over again. Then I go to modify and then click on mirror, and then I mirror from this point so that I have equal distances on both sides. Okay, so I'm going to just press escape. No, not escape, sorry. Why am I checking out here? So modify again, and then that, and then enter, or you press space bar. So that is it. I'm just going to chamfer this other corner. I did explain the principle of chamfer yesterday to you, so we're going to chamfer this other part again. But what happened to this staircase is that I want it to be like this section of the bathroom is mostly used by the people from this side, and then this section used by this. So I have to still mirror this one to face one side of it to face the other direction, right? So I'm going to select this again. Let me first of all create an equal distance between them. So I'm going to create a space here. Then I will select this again, go to my modify, and then click on this, and then mirror, right, like this, right? So I have to click there's a question here: do you want to erase the previous one? So yes, I want to remove the other one so that I don't have duplicated lines. So this is it. I have this section of the bathroom that will be used by this other section. Majority of the people will use it, and then I don't have the lifter that will be opening facing each other, right? So that there can be a little bit of management of traffic here when both people lands here. But I already have ample space here of 4.5 meter, which is enough space for people to circulate and go around the building without problem. Okay, so for the staircases, I'm just going to probably, since the width of um my beams is going to probably approximately 250. I'm going to go here, and then from here I'm going to minus 1.25, but that is not even really important. I can just start from here and then take from here. This is another landing, since it's a dock leg staircase, right? This is an open well staircase. So I'm going to start from here and creating the landing here automatically, right? So calculating this distance, you have to always calculate the size of your staircase. So this is 2.2, meaning that 2.28, that is I have to take 1.25 from here. Okay, so I'm going to offset this 1.25. So 1.25, enter. Is that 1.25.125, so that the total of it will give 250. That is the half of 250, right? If I measure from here to here, that will be the width of my beam. So that the staircase, the last riser is going to be dependent on the beam here. So that is why I'm extracting that portion there. So I'm just going to take out this one to this position. I will have just used this thickness of this wall anyway. So this is it. I have I think I still have about 2.15. So I'm going to take out 0.05 from here. Okay, 0.05. so that I will have that space to okay, taking out 0.05 from this direction to 0.05, so that I have a section to host my form work well. So 2.1 divided by zero point 0.3, so the width of my going is zero point 0.3, so I'm going to the zero point 0.3, that is 300 mm. So just offsetting this one to have okay, so this is it on this direction. So I'm just going to mirror this one anyway. I'm just going to mirror this one. I don't want to select this to have a double line there, so I'm going to mirror this one this way. I think that is fine. Then I take out this axis line from here, like this is fine. Then now I need this other space behind too, so we have 2.2, so we can have 0.05 again here and 0.05 this way. I think we have up to 2.1 now here, right? We have 2.1, so I'm still going to go with zero point 0.3. Just offset these ones and then offset, 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 offset. So let's calculate the total number of riser that we have. So 1, 2, 3, 4, 5, 6, 7, 8, making it 16 here. 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so for this shopping center, the total height that I'm estimating to go with is going to be 3.7, right? It's going to be 3.7, the total ceiling height. So if I'm having 3.7 to work with, I want to calculate the height of my riser, right? So I'm going to have 3,700, probably 3,750 or 3,700 divided by the number of risers, that is 24. I'm going to have the height of one of the risers, right? So my riser will be 1.54, so it's still within standard, right? So the minimum is 150, so I have 1.54. Probably in some cases I'm going to have 1.55, so this is okay for my riser height. Okay, for my riser, so this is okay, I can go with this one. And I was supposed to even do it before mirroring to this other side. So that is it. The next thing we are going to do here, as I told you, time engineer, we also have structural engineer. Also, I'm a trained structural engineer too, so I'm going to go ahead and do some column positioning, right? So most often, when I'm starting a particular structure, I usually go with I just assume some sizes, but there's a principle that I'm going to show you probably when we are doing the structural, how to get the preliminary size of columns to go with. So in this case, I'm just going to go with 500 by 500, so So I'm just going to go with that size. So here I have to change the layer to that column layer that we define, right? So go here. I like using it to be polyline, so I'm going to go zero point 0.5, zero point 0.5, and zero point 0.5. Then I close it here. So from here now I can start dropping the columns, right? So I'll drop one at this position, drop one here, drop one here, drop one here. So we have 7 meters to deal with when we are designing. So it's not much of a problem. I know that in BS code, if you are just a beginner, most of the advice is that you don't go with more than 6 meters span, a clear span of the column, right? So this one we are working with 7. 7 is not going to be much of a problem for us to handle, right? So again, this number of columns here in the middle here, if you are an engineer watching this tutorial, I want you to advise me on having 4 columns on this space, right? What possible solution can you go with? Do you think that all of this space we can give out a short shear wall here and it carries the whole load? So think about it. Just look at this position and tell me what can work well. Okay, what we can use there to actually have the same functionality as having that 4 column, because that 4 column is actually reducing the space, and then you have columns appearing in the hole there that I don't really want, right? So think about what we can do to take out this 4 column. Probably just provide one or something. Think about it. Let's see. Let me see how you guys can go about it. Okay, so I'm going to position one here, one here. So probably on this side I might want to have a short shear wall here, a short shear wall here again for structural stability. Okay, so I'm going to make decision about this part later. We already have a shear wall along this span here, and we have 7 meters, but this expansion joint here will need to provide another column there. So I'm going to go with since it's a five-story structure, I'm going to go with point 0.6 by 0.25, point 0.6. So I don't want the column to be protruding inside the rooms, right? So I'm going to take this one here, take another one here. So there's something wrong here. What is it? Why would the column be closed? I have to have a polystyrene space of zero point 0.5 in between these two columns. I think 0.25 is actually the problem, right? So 0.25 during design, I don't think it's going to really work. So we can extend this a bit again. Let me extend this a bit. Take it out of the bit again to um, 0.05. Okay, so this is it. I can take this two column now and position it here. Okay, position it here, take another one here, and then take another one here, so that we'll have this space in between the columns to host the polystyrene. Okay, so the width of my beam here is going to be 225, right? Not 225, 250. 250 will work well for this structure. So I'm going to take out this one. Probably I could just allow that thing to be like that and then instead reduce by the width of the column. But notwithstanding, we'll see what will go better when we are doing the structural analysis. Okay, we're doing the structural analysis and design. So most often I will not even want to have this. I want to have an eccentricity to this column. I want to push this column a little bit so that they should not be appearing on the, they should not be showing towards the hallway here. Okay, so I want to push this one to have some eccentricity. So I'm going to take it inside. Since this is 500, so we'll have 250 this way. So I want to have my beam flushing directly at the face of the column here. So what distance am I going to subtract? I have 250 here. So I'm going to take 0.125. Is that 8? So let's see. 0.125. So I have to have again 0.125 here. So that is it. It works like that. Okay, so I'm going to take this one again, shift it, and then take this 2 and extend 0.125. 0.125. That is it, right? So I'll have my beam flushing directly on the face of this column, and then I have no column showing from inside from this hallway, this circulation area, right? And also giving priority to maximum moment that will be generated from this longer span. I think that will work well. This one too, we can do the same thing, bring the columns inside, right? Let me also bring this one inside. This one inside, I think they just have to get that same priority, right? Take out this one too, bring them inside. We'll have 0.125 again there. But I think it will not work with 600 columns here. This 600 here, it will not work well. So we'll have 0.18. So we'll have to take 0.05 from this one. Let me just extend this one too, so that we'll have the same thing. 0.05. Okay, so that is it. And then this one too, I'm going to have the 0.05 to taking out 0.05, so that I have the beam flushing all on these faces. I don't want to have columns showing on this hallway. Okay, so that is it. That is it. And then what are we left with here? We're supposed to push this one here, but there's a particular design that this column will be supporting. That this design here. Okay, we have this beams, this wall here, and this design for this greenery. So we are going to extend that part. So just allow the column like that, and then we are good to go. So we're good to go. I think what again can we check? Okay, I did not select this site here, so I want to select only the column. Hold down shift to unselect the other part. So I'm going to select this again, hold down shift to unselect the line, then I'm going to just move it again 0.125, right? And then here again I have to take out this 1.05 to have it flushing on the face. 0.05. Okay, I think that is okay. And our drawing is set at this point. I'm going to just trim this axis line here. I don't want to have it along this way, so just click, hold down, and then drag to delete multiple lines, right? Okay, so that is it, and this is just the idea for the shops up. So you want to start your alignment or your column positioning from the ground floor. Okay, So this is it, and the basement section of this, I'm just going to delete this one. Since I already have the idea in my head, this is what we are going to go with on the ground floor. I think this is almost functioning like the shops area, the one with the shops. So because I've already divided to have shops, okay. So I'm going to copy, move this one so that I bring it closer to the axis. I said in my first video that for you to copy, I think the second video, you have to have to bring it closer to 0 0. You have to type 0, comma 0, enter. So you have it closer to the 0 0 exit point. Okay, so it's closer to that point. So this is my lifter position, everything is set out. So I'm going to take this one, assuming that this is going to be the third floor, right? So I'm going to go up again and just drop it, dragging the copy, and then this copy here, I want to make it to be the basement. This is the basement section of it. So I'm going to just take out these lines, and then that is it. That is the idea here, is the idea that we have here. So just drag, delete this. So the idea for the basement, the is probably going to be used just for storage, okay, like warehouse to pack stuff. But because the land is not just that, it's not that slopey that is going to permit us to have a driveway, but we can still excavate anyway. So it depends on the client at the end of the day. If you want the basement to be used for parking, right, we can still create a ramp that goes round, okay. And that, I think that will work well for this, because this space is too big. Probably just one side of it could be used as a magazine, right? So this is the third floor. This is the I think, okay, that is it. And then I want to drag this one again to create the ground floor itself. So I'll move this one to this position. I think I should start by going up. So take this one right up there, then copy this one, copy it again, and bring here to have the ground floor, right? So this will be the ground floor. So on the ground floor, I want to have this entrance, because the main entrance is here. I want to have like 0.6, a small projection inside. So it's just for, let me see on the picture, I'll show you. You see this small projection here, I think it's more than 0.6. Let's take like 1 meter before we have the sliding door, right? Take like 1 meter. So I'm just going to move this one again, 0.4. So I have 1 meter there. Move this one again, 0.4. Yeah, then we'll trim this one, trim this one, remove this one here, remove this one, and this one. So we have that entrance on both sides. So I don't actually need these lines on the ground floor. So I delete this, and then take out this one and this. So they are going to decide on the spot to have control posts for payment and stuff like that. So this is going to be the decision of probably when they already finished building. So we are more concerned about the aesthetic here. I'm still going to, I already have ideas on how to go about it. Again, if you have a particular way to go about it, can you share your drawing? Probably because you'll be following the same things. Share your own drawing while positioning the control post and the payment decks, okay. Share it to the WhatsApp group, my WhatsApp group, that the link is going to be on in the comment section, right? So just click there, and then you can share your drawing when you join the WhatsApp group. We see where you position your decks, your payment decks and control posts. So we'll see that there, right? Okay, so I think the same thing this way. I'm just going to take out these lines. Okay, okay, take out this line, take out this line, and that is it. So the next part, so since the first floor is going to be still shopping center, so we are still going to have this on the first floor, right? So the ground floor and the first floor is identical. The second floor now is where we have the shops, right? So the first floor is where we have the shops, so that will be it here. The second floor, sorry. So the third floor is the African cuisine, right? So African cuisine is still going to be something like the ground floor, right? So it's just space for restaurant. We're going to decide the space for the kitchen, and then something like that. So this is it. And then the last floor, where we have the fourth floor, we'll have swimming pools, right? So I'm going to use this one, extend it up to this position, right? And then here now we want to have our swimming pool starting from this wall. We are not going to start on this other wall anymore, so we want to start the swimming pool here and ends at this position, right? So the man wanted a very big swimming pool. And then we can take out this one, take out this one. So this is going to be the position for my swimming pool, right? So take out this one, take out this one. This is the position for the swimming pool. So I have open cabaret at both sides here, and then we have the swimming pool in the middle, right? We have our swimming pool in the middle here. And then again, what else can we add here? Or what else can we add? Probably one side of it could be used as a stage. Oh, if you think about it, this is about 10 meters swimming pool. So you see, that's 10 meters. When you take out the wall, so it's 10 meter by 4.5, so or 4.4. I think it's a very big swimming pool to have here. So we are going to see how to design this and calculate the load of the water acting and transfer the load to these columns, right? So just stay tuned to Time Engineering Academy and let's see what we can do together. I think this wrap up the final stage of preparing the drawings to be exported in Revit. So our next video is going to be Revit modeling. Okay, we're going to dive straight into modeling our structures, and then probably that will take like 3 videos, and then we'll move straight to rendering, and then after that we'll go back to the structural analysis and design, right? So this is it for this other part in AutoCAD. Do well to prepare your drawing like this so that you follow along. And I told you again in my first video that the best tip for you to work is actually taking a real life project, so that at the end of the day you can put in your archive, you study, you want to learn a particular software, that is how you go about it. Take a real life project, stress yourself, so that at the end of the day you can study and see how to go about it. Okay, so that is it for this video. Please do share my video, because it's really discouraging somehow for a YouTube starter, a YouTuber that is just starting, right, a beginner. But as I told you, I'm doing this for us to have an environment where we can share knowledge. So I'm here with you guys. I'm going to be here no matter what. So whoever is listening or taking part in my video, please do share with your friend, comment, subscribe to my channel, and let's see how it goes. This is going to work out, right? So as I promised, we are going to do everything from start to finish. So I remain your guy, Mr. Time, again from Time Engineering. Do have a blessed day and take care of yourself.